Good evening everyone. Good evening everyone. Welcome to India's largest e-learning platform. GATE Unacademy. GATE Unacademy. We are very happy to share with you that Unacademy has successfully completed 5 years yesterday. Unacademy has successfully completed 5 years yesterday. So served thousands and lakhs of students so far. As I told you, Unacademy is a bridge between the dreams and success of many students in India. So we're very happy that Unacademy successfully finished 5 years. 5 years so far. Okay. Okay, let's start discussion of today's class. So as I told you, the subject which I am dealing is with electronic devices. This is going to be the 8th lecture. That is Semiconductor Physics 7, Part 7. The first one, the widest difference is the first one is only introduction. It was only introduction. Okay, now. So those who are attending for the first time, I should tell you about myself. Myself is Shravan Kumar. I have 10 plus years of teaching experience in various engineering colleges. I worked as an associate professor as well as assistant professor in one of the top engineering colleges. Right. So I have master's degree from JNTU Hyderabad in VLSI system design. I have mentored more than 10K students for GATE and ESE. And my areas of interest are good evening Pallavi. And my areas of interest are EDC, where we are discussing right now. The subject which we are discussing right now is EDC. And this carries nearly 10 marks minimum. 10 marks minimum in GATE. 10 marks minimum. This year we may expect more than 10 marks for EDC, sir, in 2021. We don't know how it is going to be 2023, but for 2021 we are going to have 10 marks. 2022. So next analog electronics we have analog electronics. So this also covers 9 to 10 marks. Digital electronics is 9 marks. EMFT is also 9 to 10 marks. Very rarely you'll get the 10 marks for this also. Very rarely. So I'm trying to finish this on YouTube, which we are listening to me right now. And analog electronics, I'm trying to cover this is an Unacademy app. So for those who don't know about this, just go to Unacademy app and download. I'll in the next slide I'll explain you how to do it. Okay, next digital. We'll finish off once we are completing with the EDC and analog, and we'll go to digital or in parallel. We'll see the structure later, and we'll try to make as early as possible to discuss. Tejashwini, good evening. Good evening, Tejashwini. And EMFT is another subject which we are dealing. So the steps is those who don't have Unacademy app, I request you to go to the Play Store and get the Unacademy Learning app. So just search Unacademy Learning app. You'll get this. So once you can see this. So click on install. As you have a habit of installing many apps, this is also one of the app, Unacademy app. which is used by lakhs and lakhs of students in India. The steps 3 is you have to manage your goal. That means you have to select your goal. So we have many goals here, like in NET exam, we have a GATE exam, you have NEET exam. So NEET for PG also we have. So IIT exam, and this is our discussion GATE ESE. So those who are preparing for IIT also, IIT jam and NET exams, NEET exams, all these things. So I request you to ask your friends also, your friends and your juniors or your brothers and sisters at your home. Also, you can suggest them to choose this Unacademy app, right? So in Unacademy app, you will have three types of classes. You have plus classes, you have free classes, you have special classes, and apart from this, we have YouTube live classes. That is what right now we are listening. Right now you are listening. Okay. So free courses, which are also free, special courses also free. So for this, you should use my code SVS10. Unlock SVS10. Use. So now we have something called plus. So why the plus is, sir? The plus is for those students who are very serious, and so of course you are also serious. That is the reason why you are here. Of course I can understand, but still this is for those students who will pay amount and learn, right? So what is the advantage of having this plus course, plus subscription? Plus subscription will give you one-to-one interaction with the faculty. For every 4th hour, you're going to be interactive session, that is problem solving or question doubts clearing session you will have. Every 4th session is going to be doubts clearing session. And the most important thing is, as I told you, GATE is not just about writing, reading. GATE is all about practicing. So you need to practice as many tests as possible. Subject-wise tests, two subjects tests, three subjects tests, overall test. Like this, you have to practice as many tests as possible. As many, you may be very good at one subject, you may not be good at other subject. Or let's say you are good at all individual subjects, but when you are trying to write all the exams at a time, all subjects at a time, you may not recollect all the formulas which you are supposed to do. So for that, what you need to do, sir? Practice. Practice is required. Practice is required. Practice is required. So how will you practice? Don't just think that you will get every answer while you are writing exam. So you have to practice. Write the test series. Write test series. Test series is very much important. Test series. For that, we have many test series in plus. We have many test series in plus. Subject-wise test, individual test, and group test. Right? So many things we have available here. That is very much important. Right? So how to get that? Just select plus and get subscription. Get subscription. Click on subscription, and you will get an option of 12 months and 24 months. As I told you, for those who are preparing for 2022, I would recommend you to select for 24 months, because you will get a lot of time, and this is very much important. So even for those who are preparing for 2023 also, I would recommend you to go for either, please go for 24 months rather than going for 12 months, right? So, and the code which is useful to do all these things is my code SVS10, 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 and apply. Just click on apply. So you'll get 10% discount on it. You'll get 10% discount on it. Mahendra, good evening. Good evening, Mahendra. So you'll get 10% discount. 10% discount. So the fee structure may be changing, as I told you. Different days, different fee structure will be coming depending on the student's availability or whatever, right? So you can have use debit card, EMI, UPI, wallets, net banking, all these things you know. I need not repeat it again, right? Okay. So we'll go to the next slide. Yeah, this is the problem. This is a very important problem. This is a very important problem which we discuss. This problem has come. So this today we are going to discuss mostly all the problems, sir. Mostly we will discuss only problems. I think I have given you. I think I have given you some homework. Let me check what happened yesterday. Let's go back and see what happened yesterday. So in the last class, what we have discussed, sir? Actually, in the last class we have discussed a formula summary. All these formulas we have discussed. So quick go through. Q is the charge of electron 1.6 into 10 to the power minus 19 coulombs, which you already know. I is equal to dq by dt. E, what is this? Electric field. Electric field is a force per unit charge. Force per unit charge. Force per unit charge. Newtons per coulomb. Newtons per coulomb. And it also equal to minus dV by dx, which is units are going to be V by m. And the potential V. Potential V is the integration of this electric field from x0 to x. What is the definition? By definition, what is V, sir? V is the work done against electric field to move and a positive charge from x0 to x, which is against to this minus indicates against to the field. HF is the photon energy which will be released when an electron is moving from higher level to lower level. That is W2 to W1. So HF is equal to W2 minus W1, which is also equivalent to what is W? Energy is equal to EQ. Energy is equal to EQ. So this can also be written HF is equal to E2 minus E1 into 1.6 into minus 19. And this is a wavelength. This is a wavelength that is equal to 1.24 by E2 minus E1 in micrometers. If the problem is asking, if the examiner is asking you to write in terms of Armstrongs, it is going to be 12,400 by E2 minus E1. 12,400 by E2 minus E1. This is what we discussed. And energy gap is equal to 1. For silicon is going to be 1.21 minus 3.6. That is 3.6 10 to the power minus 4 into T. T is the temperature. T is the temperature at which we are measuring. This is. So for germanium, it is going to be 0.785 minus 2.23 10 to the power minus 4 T. So for T is equal to 0, you are going to have 1.21 and 0.75 respectively for silicon germanium. And T is equal to 300. So it is going to be 1.1 or 0.72. 1.1 for silicon and 0.72 for germanium. At T is equal to 300 degrees Kelvin. At T is equal to 300 degrees Kelvin. And drift velocity V is directly proportional to the electric field E. And the proportionality constant is called as mobility. And the standard values of mobility. So these you need to remember. Every time I am telling you, this is you need to remember. Okay. Germanium has sorry. Don't think I have a corona. Right? Nowadays, so for everything, everybody is feeling that there is a problem. Right? Okay. Germanium 3800. This what is mobility? Electron mobility for germanium is 3800. For germanium, whole mobility is 1800 centimeter square per volt second. The units for mobility or meter square per but here it's going to be centimeter square per volt second. Silicon, what is the mu and electron density is going to be 1300. Sorry, mobility of an electron is going to be 1300. Mobility of holes is 500, which is very less. And we have seen conductivity is equal to NQ mu. This we have seen conductivity is equal to NQ mu, and charge density rho is equal to NQ. This is going to be charge density NQ, and current density J is equal to J into sigma E, where sigma is the conductivity. This is now just discussed. For intrinsic concentration, Ni is equal to N is equal to P. That is intrinsic concentration Ni is equal to N is equal to P. And Na square is equal to A naught into T power T cube into E power minus Eg naught by Kt. And what is that intrinsic constant? So sometimes in this also you need to remember, as I told you, very important. Intrinsic concentration Na is equal to 2.5 into 10 to the power 13 atoms per centimeter cube for germanium. For silicon, it is going to be 1.5 into 10 to the power 10 atoms per centimeter cube. And mass action, the product of number of holes into number of electrons, number of holes into numbers of electrons is equal to a constant. That constant is equal to Na square. For extrinsic semiconductor, that is N-type, for N-type extrinsic semiconductor, this Nn is greater than Ni is greater than Pn. This is going to be Pp is greater than Ni is greater than Np. Always remember this. Okay. From electrical neutrality principle, Nd plus P is equal to Na plus En. What is this, sir? Positive charge and negative charge. Equal to electrical neutrality. Always should be equal. So from this Nn indicates electrons in n-type material, that is Nd donor concentration, and holes in n-type material. Holes in n-type material is going to be Na square by Nd, Na square by Nd, Na square by Nd. For p-type, that acceptor concentration, Pp is equal to Na, and this Np, that is electrons in a p-type material, is equal to Na square by Na. This is the formula 17th. The 18th formula is going to be conductivity of semiconductor. For semiconductor, as I told you, both mu and mu p and mu n will exist because the current is due to both electrons and holes. That is called n q mu n, p q mu p, right? If you want to still write something, you can write like this. You can write like q into n mu n plus p mu p. Not required, but just for this. So then current density J is equal to n q mu n. This is going to be sigma. This is again same. So intrinsic concentration as Ni is same for both of them. N and P are same. So Ni will get. So this formula is also useful today. Today one of the problem is based on this only simple this problem. Okay. So mobility mu is proportional to T power minus m, and where m is equal to 2.5 for electron and m is equal to 2.7 for a hole. And resistivity, this is also important. Rho resistivity is equal to 1 by nq mu. So I think we have solved this problem. 2 problems or 3 problems we have solved. I think I asked you to do this homework. Determine the concentration of free electrons and holes in a sample of germanium at 300 kelvins. So I don't know how many of you did sir homework problem, and I asked you to comment. In the comment box. You did not do it, right? You did not do it. No one, Mahindra, Teshwini, whoever is online. I asked you to do it, right? Sir, don't just simply listen, sir. You have the ability to do it. Don't think that these are all gate problems which are extraordinary. No, sir. If you start preparing, all these things will be easy. You need not worry. I asked you to do this problem. I don't know how many of you done. And this is also same. This is also I think I asked you to do as a homework. Okay. I think this is what we have done. So we'll go for today's session. First, let us do this problem, sir. And we will go to the problem. This is a 2 marks question, which was asked in the GATE 2017. Set number one. Understand the problem very clearly. The dependence of drift velocity of electrons on electric field in a semiconductor is shown below. Drift velocity is V of electrons on electric field is E. In the semiconductor shown below. So what is saying, sir? This is electric field E, and this is a velocity V. This is a diagram. Okay. The semiconductor has a uniform electron concentration of. Okay. What is saying, sir? He has an electron concentration N. N is equal to 1 into 10 to the power of 16 atoms per centimeter cube. Very good. And charge, with this we already know, Q is 1.6 into 10 to the power of minus 19 coulombs. If a bias voltage of V applied, V voltage V of how much voltage, sir? How much voltage? How much voltage? How much voltage he is saying? He is applying 5 volts. He is applying 5 volts across the length of, across a 1 meter region length. So L is equal to 1 micrometer of the region, the semiconductor. The resulting, he is asking J. How much is the current density J? And you see what is asking in terms of kilo amperes per centimeter square. These units are important, sir. Kilo amperes per centimeter square. Kilo amperes per centimeter square. Okay. So now what is the formula? Shall we start? So that is the formula. So what is the formula for J? J is equal to N Q. Tell me. Can somebody tell me what is the value? Formula J, current density J, NQ mu into E. Mu into E. Mu into E. Mu into E. Nobody is responding. Nobody is responding. Okay. So he is asking for this. How much? Acha, from the given data, so from this we can calculate. So we need mu, right? Mu n we need. So for that first we need to, first let us calculate mu n. So we know that drift velocity V is equal to mu n into electric field. So from this mu n is equal to V by E. Mu n is equal to V by E. So how much is mu n? What is the V value? V value is going to be 10 to the power of 7 by E is 5 into 10 to the power of 5. Acha. 5 into 10 to the power of 5. So how much is it going to be, sir? I think mu n is going to be 20 just. Mu n is going to be 20. Mu n is going to be 20. So remember this. Remember this. Okay. Now J is equal to N Q mu n into E. Did he give E, sir? No, he did not give E directly. But what he's saying, sir, he's saying N Q mu n into V by L. V by L. So what is the value of N? What is the value of N? 10 to the power of 6. 10 to the power of 6. The Q, 1.6 into 10 to the power of minus 19 coulombs into mu n is 20 we got. And what is this, sir? V has given 5. V has given 5. And length is 1 into 10 to the power of minus 6. But what is asking, sir? Is asking in terms of centimeters. Remember this. Most of the time you will do the same mistake. So okay, good Tejaswini, good. So J is equal to 10 to the power of 6 into 1.6 into 10 to the power of minus 19 into 20 into 5 into this. I'll convert this into centimeters. It's micro, right? So by 1 into 10 to the power of minus 4. This will also become centimeters. So can you tell me what is J value? What is J value? This is 10 to the power of 16, right? I think this is 10 to the power 16. I'm sorry. 10 to the power of 16. So this is going to be 100. This is going to be 10 to the power of okay 16. So 1.6 into 10 to the power of minus 16. This is nothing but minus 10 to the power of minus 3. 10 to the power of minus 3. This is going to be 100 into 10 to the power of 4. 10 to the power of 4 that is going to be 10.6 into 10, so it's going to be 1000 amperes per centimeter square. So, but he's asking in terms of K. He's asking in terms of K. Tejashwini, what 1.28 into minus 13 amperes per meter square? 1.28. From where did you get 1.28? From where did you get your 1.28? Just see. So J is going to be, he's asking in terms of K, right? Kilo amperes. Your answer is correct, Mahendra. Your answer is correct, but the asked the question is in terms of kilo amperes per centimeter square. Kilo amps per centimeter square. So this is the answer. This is the answer. You need to check. Okay. Pallavi correct, and Tejshni also correct. All the three of you are correct, but the only thing is you should mention what it did ask. He asked in terms of kilo amperes per centimeter square. Kilo amperes per centimeter square. Units are important. So he may give an options like this. He may give an options like this. He may give an options like this. Option A. 1.6. B. 1600. Sorry. First you will give right option only. Wrong option will give. He'll give first 1600. He'll give B 160. C 1.6. D 16. Definitely. Sir, how you got velocity, Krishnaveni? How you got velocity and E values in the given problem only there, na? Here, you can see here. This is what he has given: drift velocity and electric field. Here, the values are there, na? At this point only, right? So maximum values I am considering. This is a linear, right? This is a linear, right? So that is why. So that is what you have to remember. Correct question. Krishnaveni, correct. So very good. So I got these values. V and E from. He is very clearly mentioning the dependence of drift velocity of electrons on electric field in a semiconductor is shown below. Did he mention any other values here? You may get confused if he mentions any other value. He did not mention any other value. So he mentioned only here, this is the value of E. This is the value of V. Clear? Okay. Okay, Krishnaveni, okay? Okay. So what happens, sir? So definitely all will you write. So this is what your answer you mention, and you'll get 0 marks. You'll get 0 marks. Why, sir? He's asking in terms of kilo amperes per centimeter square. And one more mistake what you will do is, here also you will not convert them into, this is also important, sir. This is important conversion. This is important conversion. This is also important conversion, because from this is meters to centimeters conversion. Centimeters conversion is important. As I told you, units are very much important. Why not you substituted E value from the graph indirectly? See, no, 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 no. See, E is saying at 5 volts. Did you know where the 5 volts is? And the distance is 1 micrometers. Do you know where 1 micrometer is? This is completely, he is saying that this is a dependency. That is the reason why I did not substitute here. You may ask me to substitute 5 into 10 to the power of 5 here. 5 into 10 to the power of 5 here, or 10 to the power of 6 here. But did he mention the length? Do you know the length at what place? Here? Did he mention any length? No, he did not mention. So because of that I have considered this. Because of that I have considered this. There is a difference. Okay. So according to you, this V by L what we got is going to be 5 into 10 to the power of 4. So he's asking somewhere here. 5 into 10 to the power of 4. Not at 5 into 10 to the power of 5. 5 into 10 to the power of 5. Clear? Clear, Krishnaveni? Okay? Yeah, I will move on. So you'll get 0 marks. So wrong answer. What is the answer, sir? 1.6. 1.6. You'll get 2 marks. Don't think you'll give 2 marks simply. Problem is simple only. Yes or no? Problem is simple. But you should think why he has given for 2 marks. Because you may definitely confuse with this. You may definitely confuse with this. Either you may confuse with this value, or you may confuse this in conversion. In the conversion. Remember always, units are very much important. Units are important, or very important. Units are very important. Okay, Krishnaveni. So units are always important, sir. Units are always important. Be careful while you are solving the problem, right? That's what EDC is. Looks very simple, but small things matters. Small things matters. Clear? I think it is clear for you, right? Next, we'll go to the next problem. Next problem. Determine the concentration of free electrons and holes in a sample of germanium. Acha, this is homework, right? Huh? Homework problem you did not do. None of you did it, sir. Too much. Huh? At least from next onwards you should do it. Okay? Huh? I'll give you two problems today. You do it. Okay. Now determine the concentration of free electrons and holes in a sample of germanium at 300 degrees Kelvin, which has a concentration of donor atoms equal to, so donor atoms means ND as given. Entanta, sir? How much, sir? 2 into 10 to the power of 14 atoms per centimeter cube. Very good. And the concentration of acceptors, very nice. He has given Na. 3 into 10 to the power of 14 atoms per centimeter cube. So what is asking? Is asking us to determine n value, how much is concentration n, and a p value. First of all, we should know whether it is p type or n type. P type or n type. Sir, in p type, Na value will be higher. In n type, Nd value will be higher. From the given data, from the given data, so Na is higher than Nd. 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 So now this is whether p type or n type. This is whether p type or n type. Definitely it is a p type material. It's a p type material. It's a p type material. It's a p type material. Now he is asking, so when it is p type material, what we need to calculate, sir? We need to calculate Pp how much, and then we need to calculate Np how much. What is Pp, sir? Generally, Pp is going to be Na. If you think that this is exactly the value what he has given, 3 into 10 to the power of 14, wrong. This is Na dash we need to consider. Because for, you may have a doubt now, Na dash which is equal to Na minus Nd. You may get a doubt why you are this. Sir, if for a p type, what is Nd? Nd is negligible or not? But it is here, Nd is negligible? No, it is almost same. That is the reason why we are considering this excess holes only. Excess holes only here. So Pp is going to be 3 into 10 to the power of how much, sir? 3 into 10 to the power of 14. 14 minus 2 into 10 to the power of 14. So I should say this is going to be Pp is going to be simply 10 to the power of 14 Pp, that is whole concentration. Now what is electron concentration? Np formula. What is Np? Np is simple, sir. Np is equal to Na square by Na dash. Na square by Na dash. Np is equal to Na square by Na dash. So what is Na? Is there any Na value has given? Any Na value has given? No. But I have told you to remember. I have asked you to remember the values of intrinsic concentration for germanium and silicon. Intrinsic concentration for germanium and silicon. So what is given? Given is germanium. So the intrinsic concentration Ni for germanium is how much, sir? 2.25 into 10 to the power of 13 atoms per centimeter cube. This you need to remember. All the time he may not give. What is SI? SI is going to be 1.5 into 10 to the power of 10 atoms for silicon centimeter cube. See, in the first problem, did he give concentration? No, we need not this problem. Okay. So now Np is going to be Na square, that is, so this is not 2.25, sorry, this is 2.5 simply. By mistake I have written. This is going to be 2.5 into 10 to the power of 13. Okay. P type. Okay. No problem, no problem. 10 to the power of 10 to the power of 12, correct. 10 to the power of 12. 10 to the power of 12. Okay, this is going to be 2.5 into 10 to the power of 12 whole square by NA dash, that is 10 to the power of 14. So what is the value of NP? 25 is 625, that is 6.25 into 10 to the power of 24 by 10 to the power of 14. It is going to be how much, sir? Good evening, sir. Nice, sir. Good evening. 6.25 into 10 to the power of how much, sir? How much will be remaining? 10. So this is going to be the PP value. What you are asking? This is the PP value which you was asking. And this is the NP value. This is the NP value. Answers. This is the answer 1. This is the answer 2. 6.25 into 10 to the power of 12. You got 10 to the power of 12. Correct. I think I have mistaken. It is my mistake only. Correct, Tejashwini, correct. Sorry, who is answering? Krishnaveni, correct, Krishnaveni. This is 13 only. I think by mistake I have written. Here it is 13 only. So 13 here it is going to be 26 into the power of 12. Or if you want me to draw it, I'll write. To the power of 12 only. What are the units, sir? Atoms per centimeter cube. Here also it is atoms per centimeter cube. No, it's 13 only. Okay. Next problem. Here comes the problem. Next problem. Find the concentration of holes and electrons in p-type germanium at 300 degrees Kelvin if the conductivity is 100 microcentimeter square. Inverse. I think the units I have given wrongly. This is I don't think it is there. By mistake, it's a mistake, question mistake. Units are same. You do the problem. Do the problem, sir. Do the problem, sir. Do the problem. You try this problem. This was also homework, right? This is also homework problem only. Yes or no? Actually, this is also homework problem. You are not doing any homework, madam. Homework you have to do. You have to do homeworks. Okay. So what is asking, sir? Is asking find the concentration of holes and electrons in p-type. P-type material. P-type material is given. So he is asking for holes PP and NP. Concentration of holes and electrons in p-type germanium. If the conductivity as given. Conductivity. P-type material means conductivity means we'll get P, Q, mu P. P, Q, mu P. Is asking for holes concentration. This is PP is asking. So simply PP is nothing but sigma by Q mu P. Q mu P. Q mu P. Here also again, what I asked you to remember, the values of mobility. This is correct, is given. PP is equal to sigma 100 by Q 1.6 into 10 to the power of minus 19. What is mu P? So for germanium, mu P is 1800. Units are centimeter square per volt second. Centimeter square per volt second is what mu P is. So PP is going to be 100 by 1.6 into 10 to the power of minus 19 into 1800. Calculate the answer, sir. Can somebody tell me the answer? I'll tell you PP value. Calculate. It's going to be 3.47 into 10 to the power of 17 per centimeter cube is the answer. How will you calculate other one? That is asking for NP also. Asking for NP also. NP is equal to Na square by PP. What is Na square, sir? What is the Na square value for germanium? Intrinsic concentration for germanium just now we used. That is 2.5 into 10 to the power of 13 whole square by PP. How much we got? 3.47. 3.47 into 10 to the power of 13. So you just calculate this NP value. NP value correct. Krishnaveni and Tejaswini, you are correct. But can you please calculate NP value? NP value 3.4 10 to the power of 17 you got. 17. Correct, 17. I have written wrongly here. Okay. Now tell me NP value. Krishnaveni is also right. That is 0. Just you have to push 3.7 10 to the power of 17. 3.47. Tejaswini, you are right. Just let me know the answer. Let me know the value of NP. Let me know the value of NP. You do one thing. You comment. You comment in the comment box. Huh? Comment in the comment box. How much is the value? Next problem. A p-type silicon sample has a higher conductivity with an n-type sample having the same dopant concentration. Achha, is this true or false? He is asking. He is asking true or false. True or false. What's the conductivity formula? Conductivity formula. What is conductivity formula? NQ mu. NQ mu. Right? So if it is a p type, it is going to be, let's say this is n. NQ mu. NQ mu n. This is for p type. It is going to be p q mu p. What is saying, sir? A p-type silicon sample has a higher conductivity compared to the n-type silicon. Same dopant concentration. So what is saying, sir? He is saying n is equal to p. N is equal to p. N is equal to p. Right? So according to him, so sigma n. Let's calculate sigma n by sigma p. N q mu n by p q mu p. Sir, as is saying n is equal to p. N is equal to p. So let's cancel these two. Q will get cancelled. So sigma n by sigma p is equal to mu n by mu p. Sir, what is mu n and mu p for? Mu n mu p for silicon. What is mu n mu p for silicon? 1.10^9. Correct. Previous problem. Okay. Now what is mu n and mu p? Both of them are same. If these two are same, if mu n and mu p are same, then this is true. This is true. Statement is true. Is the mu n and mu p are same? Is mu n and mu p are same? Is mu n is equal to mu p? Absolutely no. No, for a silicon, mu n is 1300 centimeter square per volt second. Mu p is 500 centimeter square per volt second. So as mu n is not equal to mu p, sigma n is not equal to sigma p. So the answer is false. Answer is false. Correct. Krishnavedi is saying already dopants are same, having same dopant concentration. Same dopant concentration. So n is equal to p. That's what I'm saying. So he's already said dopant, same dopant is saying same dopant concentration, that is n is equal to p. What is we can call n and p nd. See, you think that this is going to be same. Let's say sigma n is nothing but nd. For this na. Consider this is na. So he is saying nd is equal to na. nd is equal to na. So if nd is equal to na, these two will get cancelled. So what is remaining? Mu n mu p. So the answer is false. It is not true. Clear? Clear? So answer is false, not Q. Okay, next. You also, oh, problem looks very big. Problem looks very big. See, what is the problem? A small concentration minority carriers is injected into a homogeneous semiconductor crystal at one point, an electric field of 10 volts per centimeter is applied across the crystal, and this moves the minority carriers a distance of 1 centimeters in 20 microseconds. The mobility will be above. Is asking for mobility. Is asking for mobility. What he has given? What he has given? So he has given the distance traveled. The distance traveled L is going to be 1 centimeter in a time of 20 microseconds, and applied voltage or applied electric field, saying electric field is equal to 10 volts per centimeter. Very good, he has given centimeters. What he is asking for mobility mu. From where did you get mobility, sir? Mobility is, you will get from drift velocity. Drift velocity is directly proportional to electric field. Electric field. Yes or no? That is, V is directly proportional to E, and V is equal to mu E. So mu is equal to V by E. What is V? V is the velocity. What is the formula for V? What is the formula for V? Distance traveled by time or not? Distance traveled by time or not? So I can write length, distance traveled by time, E. So mu is equal to L by ET. So distance how much traveled? 1 centimeter. It's going to be 1 centimeter by E. E how much are 10 volts per centimeter? Okay, 10. 20 microseconds. So what is the value of mu? How much is the value of mu we will get? How much is the value of mu? Simply calculate, sir. You will get some value. Centimeter square per volt second is the unit. How much is the value? 5 into the power 3. Correct, Krishnaveni, correct. It is going to be 5000. Right answer. Sir, if you look at the problem is how many lines you can see? 1, 2, 3, 4, 5. You have 5. If you look at the size of the problem, you will feel that it is going to be a very big problem. If you look at the size of the problem, you will think that the problem is very big. Is the problem big, sir? Is the problem very big? No. Is the problem very big? No. Was the problem very big? No. But answer is very simple. Don't think that correct answer only. Correct, Tejni, correct, 5000. Correct, 5000. Correct, 5000. Okay, now we'll move on. So don't think about the size of the problem. Just focus on the problem, you'll get the answer. Focus on the problem, you'll get the answer. Okay, right? Sometimes he'll give you unnecessary data also. In some problems he'll give all unnecessary data and will try to confuse you. You may think that it is a very big problem, it will can't answer. But answer is already very simple. Answer is very simple. Okay. You see this problem? ND is 10 to the power 15 by centimeter cube. Ni, intrinsic concentration, donor concentration. If the sample is additionally doped with Na, 1 10 to the power of 18 centimeter square acceptor atoms, the approximate number of electrons in the sample. Wow, this is very good. This problem is very good problem. Approximate number of electrons per centimeter cube in the problem. Nice problem this is. Think, sir, think what is saying. What is saying is, you have some semiconductor. This semiconductor has a semiconductor has an ND value of 10 to the power of 15 and intrinsic concentration anyway. This intrinsic concentration represents is silicon, or you can consider silicon semiconductor. It is an ND. Now what is trying to do? Okay. Later on it will become P-type. Initially it is an N-type because this ND, donor concentration. Now he is trying to add a Na of how much? 1 into 10 to the power of 18. So is that ND is Na higher than ND or not? Is Na is higher than ND or not? So now what happens, sir? This will become P-type material. So what is a new holes concentration? Is going to be old Na minus Nd. I can call this as Na dash is going to be 1 into 10 to the power of 18 minus, what is Nd? 10 to the power of 15. All centimeter cube only, need not worry. It's going to be, if you take 10 to the power 15 common, what will be remaining? 1, 2, 3 minus 1. So this is going to be 10 to the power of 15 into only 1, 999. Sir, what is saying, sir? The new acceptor level is going to be 999 into 10 to the power of 15 per centimeter cube. Sir, can I write aptly? This is 1 into 10 to the power of 18 only, approximately. Approximately, yes or no? Approximately, Na dash. But what is asking, sir? Is he asking for us to calculate PP, approximate number of electrons is asking. Means he is asking for, this is number of electrons in P-type. 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 What is the number of electrons in P-type, sir? This is going to be Na square by Na dash. So NP is equal to Ni, how much is given? 1.5 10 to the power of 10. Okay. Standard value, because it is silicon, 10 to the power of 10 whole square by 1 into 10 to the power of 8. So this is going to be 2.25 into 10 to the power of 20 by 10 to the power of 18. So NP is going to be 2.25 into 2.25 into 10 to the power of 2. So I can write NP is equal to 225. Final answer. ANS. ANS. Yes or no? Right answer or not? Did you get any other answer? Sir, I have considered this for convenience, sir. It's all waste of writing 999 into something. Okay, approximate value is also asking for approximate value. The approximate. Need not worry about this T. Right? This is as given to just to confuse you. So you need not worry. You need not worry. You need not worry. Okay. This is the answer. Sir, one interesting thing you should see here is, can I say PP is equal to NA dash? How much is this? 1 into 10 to the power of 18. Then what is NP, sir? NP is just 225. It is just 225. It is just 225. So PP is far greater than NP. Hence it is a P type. Is a P type. That's what we have concluded right here. We said this is P type. We assumed that this is going to be P type. Yes or no? So hence the answer is 225. The answer is 225. And this is also correct. This is also P type. Our answer is also correct. So sometimes if you want to verify cross check, you can cross check like this only. Cross check. You can cross check the answer. As you assume that initially it is P type, as you assume that initially it is P type. Yes or no? This is P type or not? This is assumed P type or not? So in the next here, by calculating the value of NP, we can prove that it is a P type only. It is a P type only. This is very much important. This is very much important. Clear? Is it clear for all of you? No? Is it clear for all of you? Is it clear for all of you? Okay, we'll go to the next problem. Next problem. I think this is also a previous gate problem only. A silicon sample with a unit cross-sectional area shown below is in thermal equilibrium. Okay. At T is equal to 300 degrees Kelvin, at 300 degrees Kelvin, and Q is equal to 1.60 to 10 to the power minus 19 coulombs. Vt, what is Vt? What is Vt? Volt equivalent temperature. That is, we will not discuss here. See, just to confuse you, he has given. No use of this. Okay, we'll see. Mu n is equal to, this is mu n. 1350 centimeters square per volt second. The magnitude of electric field at 0.5 microseconds. Acha. Okay, he's asking you to have electric field at 0.5 micrometers. Okay. The magnitude of electron drift current density. Electron drift current density at 0.5 micrometers. Oh, okay. E is asking for, B is asking for J at same distance of 0.5 micrometers. 0.5 micrometers. 0.5 micrometers. So how will you do the problem, sir? How will you do the problem? First think what about answer A. He's just asking for E. What is E? Is E nothing but dV by dx? Is E nothing but dV by dx? dV by dx? That is minus dV by dx. Minus dV by dx or not? He is asking. So for dV by dx, what you will do, sir? Minus of 1 minus at 0.5 is asking. 0 minus 0.5 micrometers by obviously it is 1 volt, right? He has given 1 volt. This is the 1 volt. This is at potential at 0.5 micrometers. Halfway through. It is halfway through. I think we have done same kind of problem when we are discussing this. So halfway through is going to be 0.5 volts. It's going to be at maximum. It's going to be V, but he's asking at 0.5. He's asking at 0.5. He's asking at 0.5. Right? So this can also be written as. This can also be written as. 0 minus 0.5. 0 minus 0.5 micrometers. So E you are going to get as 10 kilovolt per centimeter. So you have other alternate also for this. You can simply calculate E is equal to V by L. E is equal to V by L. Because electric field intensity will be uniform. See what is mentioned. Thermal equilibrium. So unit cross-section area. So E is constant. Simply you can write how much voltage you have. 1 volt. Pi. How much centimeter? 1 micrometer. 1 micrometer. 1 micrometer. But at a distance of what is asking? So electric field, wherever you are, electric field will not change, sir. Electric field will be uniform. It is uniform. It is uniform. It will be uniform. It will be uniform. So it's going to be 1 by 10 to the power of minus 6 meters. As he is trying to give us in 10 to the power of minus 4 centimeters. So E is going to be 10 to the power of 4 volts per centimeter. So similarly, I have written something like 10k volt per centimeter. Simply I have written this. Method 2. Method 2. This is method 2. right? Then he's asking for what? Magnitude of electron drift current density. Acha, okay. Current density B. He's asking for current density B. So current density B is equal to J N Q mu E. Yes or no? Yes or no? N Q mu E. N Q mu E. What he has given? He has given the value of mu n. He has given mu n. He has given mu n. He has given. Silicon sample is saying. So for silicon sample, assume what is the value of Ni. So J is equal to N into 1.602 into 10 to the power of minus 19. Mu, did he give mu? 1350. 1350 has given already. Mu n he has given. And E just now we calculated. 10 into 10 to the power of 3. How will you write the value of n? What is the value of n? Did he give the concentration value? Did he give the concentration value? Yes, he has given right here. In the problem he has given Nd. Nd is nothing but. So here J is equal to Nn into whatever this is, right? So J is equal to Nd into Q mu n into E. Calculate, sir. What is the Nd value? What is the Nd value as given? 10 to the power of 16. 10 to the power of 16 into 1.602 into 10 to the power of minus 19 into 1350 into 10 power 4. Can somebody tell me what is the answer? Can someone tell me what is the answer? Calculate the problem. Calculate the problem. Calculate the answer, sorry. Calculate the answer. Calculate the answer. What's the value of J? What's the value of J? What's the value of J? 21,600. Okay. So she is saying 21,600. Units NT? What units? Amperes per meter square. Or J is equal to 2.16 kilo amperes per meter square. Did he mention anything, sir, here? No, he did not mention anything. He just given the magnitude of the. Okay. Here minus 3, 1, 4, 5. So you click cross check this. Okay. Okay, Krishnaveni. Okay, Krishnaveni. Yeah. Shall we move on to the next problem? Shall we move on next problem? Yeah, next problem. Next problem. The resistivity of a uniformly doped n-type silicon sample is 0.5 ohm centimeter. If the electron mobility mu n, this is mu n, sir. This is mu n. Is 1250 centimeter square per volt second, and the charge of the electron is 1.0. Okay, the donor impurity constant Nd is sample. Will you please think? He has given resistivity. He is given resistivity rho. Rho is going to be 0.5 ohm centimeters. He has given, and he has given mu n 1250 centimeter square per volt second. He has given Q value 1.602 into 10 to the power of minus 19 coulombs. And what is asking, sir? He is asking for ND. 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 How will you calculate ND? So from the given data, we know that conductivity is equal to N Q mu. Ultimate is equal to mu n. Then what is resistivity? Resistivity reverse of conductivity or not? It's going to be he's saying n type. He's clearly saying it is n type, so I can use mu n, n. This is going to be n q mu n. So can I say for a n type, n is almost equal to nd, almost equal to nd, almost equal to nd, almost equal to nd. Okay. So what is asking? I'll replace this. Rho is equal to 1 by nd q mu n. Q mu n. What is required, sir? Nd is required. It's going to be rho q mu n. So Nd is going to be 1 by rho is 0.5. 0.5 this is. We know 1.6 into 10 to the power of minus 19. Then mu n is 1250. So Nd is going to be what? Calculate and tell me, sir, what is going to be the Nd value? Atoms per centimeter cube. Atoms per centimeter cube. Huh. 10 to the power of 1 into 10 to the power of 6. Correct. 10 to the power of 6 only, right? 10 to the power of 16. Okay. 16. Right answer. Good, Krishnavani. Good, Krishnavani. Your pace is correct. Prepare well. What you are doing is correct. Yeah. Very good. If you go with this pace, definitely you will be very good. You will definitely score whatever EDC is there. All EDC problems will get clear. All the marks in GATE you will get. Whether you may get 10 marks, 12 marks, whatever, you'll definitely get. Good that you're trying to learn many things quickly. Very good. I'm happy. Very happy about this. I'm happy, very happy about this. Okay. Shall we move on? Shall we move on? Yeah, okay. We'll move on to the next problem. A heavily doped N-type semiconductor has the following data. A heavily doped N-type semiconductor has the following data. It is hole electron mobility ratio. Hole electron mobility ratio 0.4. 0.4. Doping concentration 4.2 into 10 to the power of 8 atoms per meter cube. Okay. Intrinsic concentration is 1.5 to the power of 4 atoms per meter cube. Okay. The ratio of the conductance of N-type semiconductor to that of intrinsic semiconductor of the same material and at the same temperature is given by. Okay. Okay, we'll solve the problem. Okay, we'll try to solve the problem. Yes, again, first hole electron mobility ratio means mu p by mu n is equal to 0.4. Okay. N-type material doping concentration he has given. For an N-type material, what is doping concentration? Nd. Nd how much? 4.2 into 10 to the power of 8 atoms per meter cube. So intrinsic concentration Ni has given. Very good. Is 1.5 into 10 to the power of 4. So what is asking? The ratio of conductance of N-type semiconductor, that is sigma n, to the ratio of sigma I. So he is asking for the ratio of sigma n. Sigma n. Okay. Sigma n is equal to nn q mu n. Okay. Then what is this is going to be? This is going to be sigma n intrinsic concentration. Acha, okay. So this is going to be Ni into mu n plus mu p into q. Okay. Now he's asking ratio, right? It is asking for the ratio of sigma n to sigma I. So nn mu n q by ni into mu n plus mu p into q. So I can also write this as nd into mu n to q by Ni into mu n plus mu p into q. Here, why we have written, sir? Nn is equal to Nd for n type. For n type. For n type. So what will get cancelled? Q will get cancelled. And is asking us to. Acha, okay, understood. Acha, okay. He's asking for sigma n by sigma I, which is equal to Nd by Ni. Take mu n here common. If you take mu n common, this is going to be 1 plus mu p by mu n. So here mu n, mu l get cancelled. So what will be remaining? Nd by Ni into 1 plus mu p by mu n. So sigma n by sigma I is equal to, how much is Nd, sir? 4.2 into 10 to the power of 4.2 into 10 to the power of 8 by, how much is Ni? 1.5 into 10 to the power of 4 into ratio of mu p to mu n. This is mu p to mu n only, right? Okay. Going to be 1 plus 0.4 sigma n by sigma I is equal to 4.2 into 10 to the power of 4 by 1.5 into 1.4. Approximately is going to be 4.2 into the power of 4 by 2.3 into the power of 4. So it's going to be sigma 2 into the power of 4 was given option. Option B. Acha. So he has given it is as a 1, 2, 3, 4, 20,000. Answer. So option D. Option D is the right answer. Correct, Krishnaveni? Correct. So option D is the right answer. Option D is the right answer. Option D is the right answer. We'll see another problem. We'll see another problem here. It was came in the GATE 2004. GATE 2004. A silicon sample Sir, what he want to prove from the question? No, it is a simple question. It's a different, you don't want to prove anything. He's just asking for the ratio of the conductions. So generally we'll ask something, right? He doesn't want to prove anything. He doesn't want to prove anything. Krishna doesn't want to prove anything. See, don't think that there will be a reason behind any answer. He may be asking anything. So to just think new, he has given this problem. Just to change the format of the problem. To change the format of the problem, he has given something. So he would have given like this also. Mu p by mu n is equal to 2 by 5. You would have say. No, he did not say. He doesn't want to prove anything. He has just given a problem. So to trouble students, he wants to create a new kind of problem. That's it. Nothing new. Nothing new. Okay. Just to prove that something has something new. So just he has given. Okay. You don't want to prove anything. Okay. We'll go to the next problem. This has given in 2004. 2004. Wow. Okay, let us see. A silicon sample A is doped with 10 to the power of 18 atoms per centimeter cube of boron. Acha, boron. Another sample B of identical dimensions is doped with the same. Oh, same. Is phosphorus. The ratio of electron to hole mobility. Oh, is already given. Okay. The ratio of conductivity of sample A to sample B. Acha. Okay. Same thing is asking, sir. So he has given here a silicon B. Boron means trivalent. So sigma. Sorry. A sample doped. I should say boron sample A. Boron, that is trivalent as a concentration. P concentration is 10 to the power of 18 atoms per centimeter cube. Next B is phosphorus, which is pentavalent. This is doping concentration. Na. This doping concentration Nd. It is also same. Atoms per centimeter cube. The ratio of electron to hole mobility. So mu n to mu p is 1 by 3 saying. Okay. So he is asking us to calculate ratio of conductivity of sample A to sample B. Ratio of conductivity of sample A to sample B. So conductivity of sample A is a P type, right? It's going to be P Q mu P. PQ mu P. This is A. B is N type. Sigma B. It's going to be PP N Q mu N or NN. So I can also write this as NA into Q into mu P. I can write this as a ND into Q into mu N. So he's asking us to calculate sigma A by sigma B, that is NAQ mu P by NDQ mu N, and we know that this Q will get cancelled, and what will be the remaining? NA mu P by ND mu N. So I can write this as a NA by ND into mu P by mu N. So conductivity of A to the conductivity of B. So both of them are same, right? Na and Nd. Oh, need not worry. This is going to be 1 into 10 to the power of 18 by 1 into 10 to the power of 18 into mu P by mu N. So it will get cancelled. So sigma A by sigma B is equal to mu P by mu N. Did he give any other? He has given mu N by mu P as given. Acha, okay. Simply can I write this as a 1 by mu N by mu P. This is going to be sigma A by sigma B is equal to 1 by 3. So sigma A by sigma B is equal to 3. Answer is A. Option A is the right answer. You understand? You understand? Option A is the right answer. Option A is the right answer. Correct. Also, he is asking ratio only, right? The ratio of conductivity of sample A to sample B. You did not mention anything. Simply you can write 3. Simply you can write 3. Krishnaveni, you can simply write 3. Krishna, you can write simply 3. You can write simply 3. Okay? Is it okay? Okay. Oh, we are done with the problems. How many problems we have done today? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 problems we have done today, and yesterday I think 2 problems. Earlier also we have done some 4 problems. So 10 plus 2, 4, almost 16 to 17, 20 problems we have done. Almost we have done many problems. We have done many problems. Many problems. So in the next class, we will start discussing about drift current and diffusion current of a semiconductor materials. Then in the coming class, Next class. Sir, try to practice as many problems as possible. Try to practice as many problems as possible. Next class we will discuss about drift and diffusion currents in a semiconductor. In detail we will discuss. We are done with many problems and we'll start discussing about other things also, right? Okay, Pallavi, after a long back, Pallavi, welcome. After a long time, you're back here, huh? In the chat box. Hope all the concepts so far which we have discussed are clear. Hope all the concepts which we have discussed are very clear. Sir, when I am giving some homework, please try to do and post them in the comment box. Post them in the comment box. Okay, don't miss to post, right? So of course I know you'll be going to college and other things, but the thing is you need to do it. Definitely you need to do it. Then only I will also know whether you are. I think in the last for one video, for one homework, only one girl replied. I think Sandhya replied. Sandhya replied. I think clear. Okay. Thank you. So this is GATE. We have other channels also. India's #1 study channels. So we have Creatrix, GATE, Electrical and Electronics, ECE, Electronics and Communication Engineering, and Instrumentation. This is a top YouTube channel. Unacademy, GATE for Mechanical Engineering, Production Engineering, I think this is some mechanical related. And then XE is generalist. And CE, Unacademy Civil Engineering, Unacademy Civil Engineering, and you have Unacademy GATE Telugu also. Sir, Unacademy GATE Telugu is also there. This is a local language. I think you have other language also. You have Malayalam, other language also. But I would prefer you to listen in English only. So some classes are Hindi. Of course, I am not from the Hindi belt, so I'm unable to speak Hindi very well. I know only English. So Unacademy GATE Telugu is there. You can use the Telugu, those who are there. Sir, you do one thing, sir. You send these links to your friends also. Let them also know at least there is some knowledge transfer is happening for free of cost. Today homework problem, no home. Tomorrow I'll give you, because I thought we can't finish all these 10 problems today. That is the reason why I did not give. If you want me to give, I can give some. No, right now I don't have any problems. Okay. Krishnavedi, from tomorrow we'll give. Okay. So Unacademy SSC, JE, Unacademy Computer Science, Unacademy GATE questions. So this is also very important channel. So those who are very serious about GATE, they can also register for this. They can also subscribe for these channels. Unacademy electrical junction. This is especially this is for electrical people only. Electrical people only. Unacademy engineering foundation. This is for the basics of everybody. Engineering foundation means you'll get many other subjects. This is engineering Pathshala. This is also engineering Pathshala. These are the different India's top leading channels. India's top leading channels. Okay. So whenever you have time, just try to see all of them. Register them. And this is a Telegram channel where you'll get lot of notes on the subject. This is a Telegram channel. I think you are having, all of you are having some Telegram channel. This is Creatrix Gate EE. Sir, if the channel is changing, we are also planning to transfer our channel from EE to EC or somewhere. From Monday, you'll let you know. Which channel I'm going to there. Of course, in the channel, new channel also, all these old videos will be transferred. All these old videos will be also be transferred. All old videos will also be transferred on the channel, new channel. Right. For that also, we will have another new Telegram. Channel. For that also, we'll have new Telegram channel. I'll update you. I'll definitely update you about that. Okay. Clear? And you can use this referral code. SVS10. Sir, even for Unacademy subscription, not just for Unacademy, in Unacademy app, we have 10,000 courses almost. 10,000 courses. Probably it might be increased also now. So to access any of these, so you will have three types of. You have plus classes, you have free classes, free courses, and you have something called special classes. So only for plus you need to pay. For a free and special classes, you will have some time limited free subscription. For that also, this SVS 10 is useful, sir. For that also, this SVS 10 is useful. So once you use this SVS 10, you can access to all the special classes. All the special classes of the many faculty. Right? The topmost faculty are there. Topmost faculty of India for GATE and ESE. Our faculty are available. You can access all those videos. Very easily. Okay. And for plus classes, you'll get 10% discount. You'll get 10% discount on the water fee. So if it is a 30,000, a 3,000 discount you will get by using my referral code SVS10. Remember this SVS10. Ask many of your friends to use this SVS10, not only just for paying, for other purpose also. Ask them to use this. Anything else? Anything you want to ask? If you want to ask anything, you can ask me now. I have a few minutes of time. Otherwise, we can wind up today's session. Sir, in Unacademy app, in Unacademy app, I am teaching right now simple diode circuits which comes under analog electronics, I have already finished so far clippers, I think 5 classes. In detail I explained all these things. Just go watch all of them, like, and then follow me. Search SHRAVAN KUMAR Kumar with my name. Search with my name, and you'll get this. So you can watch all those videos, like and follow. On the YouTube, right now we are on electrical and electronics 101 channel. As I told you, we are trying to migrate ourselves from, probably we'll move to some other areas. We will also start another channel for PYQs. What is PYQ, sir? Only exclusively for previous year questions. Exclusively for previous year questions, we will have another YouTube channel. Another YouTube channels where all subjects PYQs will be available. I'll also inform all of you. Once it is done. Once the migration is done, I will inform all these things. Okay. Okay. Thank you. Okay. Thank you for the day. Yeah. Thank you for all those who came online and who are seeing offline. Right. I wish you all the best for those who are writing 2021 and 2022 GATE exam. Right. So that's all for the day. We'll stop. We'll catch up again. In the next class. As tomorrow is Saturday, we will not have any class, YouTube class. No YouTube class because it is a Saturday. Tomorrow is Saturday. We don't have any YouTube class. So probably we'll catch up on again Monday. We'll catch up again on